It was the summer of 1977. The world was immersed in the cold shadows of the Cold War, with nations locked in a race for supremacy. But amidst the tension and uncertainty of geopolitics, humanity reached for the stars. In the vastness of space, something extraordinary was about to unfold, something that would change everything we knew about the cosmos. NASA, the United States Space Agency, had a bold new mission to explore the farthest reaches of our solar system. But this was not just any mission. This was a journey that would push the boundaries of human knowledge, sending 2 spacecraft far beyond the planets we knew into the uncharted territories of space. These spacecraft would become humanity's most ambitious Voyagers. Their names, Voyager 1 and Voyager 2. The story of the Voyager missions begins long before their launch, in a world filled with questions about the universe. Scientists and astronomers had spent centuries staring at the stars, wondering what lay beyond the planets they could see. What mysteries did the outer reaches of the solar system hold? What was out there in the deep, dark unknown? In 1972, NASA unveiled the idea of sending spacecraft to study Jupiter and Saturn. It was a time when the technological advancements of space exploration were beginning to blossom. However, this mission would not just stop at Jupiter or Saturn. The real dream was to send spacecraft beyond, into the unknown regions of space, where no human had ever gone before. The plan was ambitious, even by NASA standards. The 2 spacecraft, Voyager 1 and Voyager 2, were identical twins, both equipped with a series of scientific instruments to gather data about the gas giants of the solar system. But there was more. The mission also carried a message to the stars, a message of hope, a message from humanity to any intelligent life that might exist beyond the Earth. But before they could become the legends they are today, these spacecraft were nothing more than an idea on paper, a dream that seemed far beyond reality. The planning, testing, and engineering were painstaking. The spacecraft had to be able to survive the extreme conditions of space, including the intense radiation of the gas giants and the freezing temperatures of the outer solar system. They had to be self-sustaining, able to transmit data back to Earth across vast distances, and endure the long journey without human intervention. This was a challenge unlike any that had been faced before. Finally, after years of planning and development, the launch date arrived. On August 20, 1977, Voyager 2 was the first to blast off from Earth, followed shortly by its twin, Voyager 1, on September 5, 1977. With these launches, humanity embarked on a journey into the unknown, a journey that would forever alter our understanding of the universe. As the rockets carrying the Voyager spacecraft soared into the sky, there was little fanfare. In a world filled with political turmoil, the launches were a fleeting moment in time. But in the quiet of space, something remarkable was taking place. Voyager 1 and 2 were on their way to becoming humanity's messengers, venturing into the depths of the cosmos on a mission of discovery. Both spacecraft had a common goal, to study the gas giants Jupiter and Saturn. But while Voyager 1 trajectory would take it closer to the planets, Voyager 2 was set to take a different path, one that would ultimately carry it to Uranus and Neptune, the outermost planets in our solar system. The excitement among scientists was palpable. The missions were risky, yes, but the potential for discovery was immense. For decades, astronomers had gathered information about the planets using telescopes, but there were so many unanswered questions. What did the clouds of Jupiter look like up close? How many moons orbited Saturn? What mysteries lay in the frozen expanses of Uranus and Neptune? Voyager 1 and 2 were about to answer these questions and more. Their journey would take them into the heart of the solar system's most fascinating worlds. But perhaps even more intriguing, they would uncover secrets about the solar system that no one had ever expected. The initial moments after the launch were full of uncertainty. Would the spacecraft's instruments work as planned? Would they survive the harsh environment of space? Would they reach their targets? No one knew for sure. But the mission's directors had faith in their creation. These spacecraft were designed to go where no spacecraft had gone before. They were built to endure and to send back data, to reveal the solar system's secrets and share them with the world. The first major milestone came in 1979, when Voyager 1 and 2 reached Jupiter. As the spacecraft neared the gas giant, they sent back images that were nothing short of extraordinary. For the first time, humanity saw Jupiter's famous red spot up close, a swirling storm that had been observed from Earth for centuries, but never truly understood. The spacecraft also uncovered a remarkable fact about Jupiter's moons, Io, Europa, and Ganymede. Io was found to be a volcanic world, constantly reshaped by its erupting volcanoes. Europa, on the other hand, was discovered to have a smooth, icy surface, hiding a potential ocean beneath. The images and data from Jupiter were unlike anything that had come before, but even greater surprises awaited. Voyager 1, after passing Jupiter, was sent on a path to Saturn, while Voyager 2 continued on its trajectory toward the ice giants Uranus and Neptune. As Voyager 1 approached Saturn in 1980, scientists held their breath. Would the spacecraft send back the detailed images and data they hoped for? Would they be able to see the intricacies of Saturn's iconic rings? The answer came swiftly, as Voyager 1 sent back the most detailed images ever captured of Saturn. The spacecraft revealed the complexity of Saturn's rings, millions of icy particles, each moving in perfect harmony, creating a cosmic ballet. The discovery wasn't just about the beauty of the rings. It was about understanding their structure and their history, how they formed, and what they might tell us about the early solar system. These discoveries were groundbreaking, and yet they were only the beginning. By 1983, Voyager 2 had reached Uranus. The spacecraft made history as it provided the first close-up images of the planet, revealing its tilted axis and faint ring system. Then in 1989, Voyager 2 made its closest approach to Neptune. It discovered that Neptune's atmosphere was dynamic, with incredibly fast winds and mysterious dark spots. The most striking discovery was Triton, Neptune's largest moon, which had geysers erupting from its icy surface. But these discoveries were not just about the planets. As Voyager 1 and 2 continued their journey through the solar system, they began to reveal the true nature of space itself. They uncovered the solar system's boundary, the edge of the influence of the sun's magnetic field, where the cosmic environment changes dramatically. As the spacecraft crossed this boundary, they encountered the interstellar medium, a place full of cosmic particles and radiation unlike anything seen before. This marked the beginning of their journey into the unknown reaches of interstellar space. As Voyager 1 and 2 ventured further into the unknown, their mission grew even more mysterious. The spacecraft had a special goal: to carry humanity's message to the stars. On board each spacecraft was a golden record, a 12-inch disc containing sounds and images that would serve as a message to any potential extraterrestrial civilizations. The idea was simple. If an intelligent species ever encountered one of the Voyagers, they would have a snapshot of life on Earth, a message from humanity to the cosmos. As the spacecraft passed the planets they had studied and moved farther into space, they carried this message, silently traveling through the endless void. And yet, despite the distances they were traveling, the Voyagers remained connected to Earth, sending data back to the scientists who had devoted their lives to the mission. Their data would provide answers to questions that had been asked for centuries, as well as pose new questions, ones that humanity had never thought to ask. But the journey was not without its risks. The farther the spacecraft traveled, the weaker the signals became. As Voyager 1 and 2 moved further away, they began to encounter a different kind of silence, one that only deepened the mystery of their journey. Would they continue to transmit data, or would they eventually become silent relics of a distant past, floating forever in the cold emptiness of space? Even as the spacecraft pushed deeper into the cosmos, their legacy was already being written. Voyager 1 and 2 had opened up a new frontier of space exploration, taking humanity's curiosity and wonder to places once thought unreachable. And as they moved further into the universe, they left behind a trail of discoveries, both known and unknown, that continue to shape our understanding of the cosmos to this day. This first part sets the stage for the incredible journey of the Voyager spacecraft, using cinematic and engaging storytelling. It introduces the mission, the challenges, the discoveries, and the profound mystery that continues to surround these two remarkable machines. The year was 1979. And the two spacecraft, Voyager 1 and Voyager 2, were well on their way to unlocking the mysteries of our solar system. As the first images of Jupiter came back to Earth, scientists sat on the edge of their seats, waiting for the moment when the spacecraft would send back their findings. No one knew exactly what to expect. Jupiter, with its swirling clouds and mysterious red spot, was unlike anything humanity had studied before. For centuries, astronomers had been gazing at this gas giant through telescopes, but now, for the first time, a spacecraft would be close enough to see it all up close and personal. It was a moment that would change everything. As Voyager 1 and 2 neared Jupiter, the excitement among NASA scientists was palpable. The spacecraft were not just passing through the solar system. They were about to unveil some of the most dramatic, unexpected discoveries ever made. Jupiter, with its vast atmosphere, was a world of contradictions. On one hand, it was a majestic gas giant, a planet with no solid surface, made up of swirling clouds and enormous storms. But beneath that beautiful surface there was more to discover, more than anyone could have imagined. On March 5, 1979, Voyager 1 made its closest approach to Jupiter, sending back the first images of the planet's cloud tops. These images revealed a landscape of turbulent, multicolored clouds, vast and ever-shifting. But it was not just the cloud patterns that captured the world's attention. The Great Red Spot, a massive storm that had been observed on Jupiter for centuries, was finally seen in its true size and power. For the first time, humanity could see the swirling, reddish winds that stretched across the planet. The storm had been a subject of fascination for astronomers for years. Some believed it was a permanent fixture of Jupiter's atmosphere, while others wondered if it was a temporary phenomenon. The Voyager spacecraft answered that question. It was not only real, but it was enormous, large enough to fit 3 Earths inside of it. This was only the beginning, but the most startling discoveries didn't come from Jupiter itself. The moons of Jupiter were, in many ways, more fascinating than the planet they orbited. Jupiter has at least 79 moons, and as Voyager 1 and 2 ventured deeper into the gas giant's gravitational reach, they began sending back images of these moons, each more intriguing than the last. One of the first surprises came when Voyager 1 captured the eruption of volcanic material from Io, one of Jupiter's moons. Io was unlike any moon that had been discovered before. Most moons are cold, icy, and lifeless, but Io was different. It was alive. The Voyager spacecraft revealed a moon that was being constantly reshaped by volcanic eruptions, some of them larger than anything seen on Earth. There were no cold, barren plains on Io. Instead, there were vast plains of lava, mountains, and active volcanoes spewing sulfur into the atmosphere. The images from Voyager confirmed that Io was a volcanic world, the most geologically active body in the solar system. As if that weren't enough, Voyager 1 also sent back an image of Europa, another of Jupiter's moons, revealing a surface that appeared to be covered in a smooth layer of ice. Europa's ice was strange, brittle, cracked, and seemingly shifting. It was unlike anything scientists had ever seen. Some scientists began to wonder if beneath the icy surface there might be liquid water, an ocean hidden from view. The idea that there could be water on Europa, or perhaps even the conditions for life, set off a new wave of scientific excitement. Could this frozen moon harbor life? Voyager 1 findings would spark a series of missions dedicated to exploring Europa's icy mysteries, including the recent Europa Clipper mission, set to launch in the coming years. As Voyager 2 approached Jupiter, it too became a key player in the exploration of this gas giant and its moons. The spacecraft took an even closer look at the planet's moons and sent back detailed data about their surface features. The scientific community was now able to confirm that Jupiter's moons were much more than just rocky or icy satellites. They were worlds of their own, each with unique characteristics, atmospheres, and geological activity. The discoveries at Jupiter weren't just about what was visible to the naked eye. The spacecraft also collected detailed measurements of Jupiter's magnetic field, radiation belts, and atmosphere. These measurements were invaluable in understanding the powerful forces at work on and around Jupiter. One of the most remarkable findings was the discovery of Jupiter's magnetosphere, an enormous magnetic bubble surrounding the planet. This magnetic field was so strong that it affected the surrounding moons, creating intense radiation belts that could be dangerous for any spacecraft that ventured too close. But Voyager 1 and 2 didn't stop there. As the spacecraft continued their journey through the solar system, they sent back data that began to reveal a deeper, more complex understanding of the nature of gas giants and their role in the solar system. For the first time, scientists had a front-row seat to Jupiter's turbulent atmosphere and complex magnetosphere. These discoveries were invaluable not only for understanding Jupiter, but also for future missions to other gas giants, including Saturn, Uranus, and Neptune. But there was more to come. As Voyager 1 moved on to its next target, Saturn, it was clear that the greatest discoveries were yet to be made. Voyager 1 flyby of Saturn began in 1980, and it was nothing short of extraordinary. Saturn, with its iconic rings, had long been a symbol of beauty and mystery. But now, for the first time, Voyager 1 was about to reveal the true nature of this giant planet and its incredible ring system. As the spacecraft approached Saturn, scientists at NASA anxiously waited for the first images to come through. They knew that Saturn's rings were beautiful, but no one knew just how intricate and stunning they would appear up close. When the first images of Saturn came through, they were unlike anything ever seen before. The rings were not just solid bands of dust and ice. Instead, they were made up of millions of particles, each moving in a delicate dance around the planet. Some of these particles were as small as dust grains, while others were as large as mountains. The spacecraft's images revealed the complexity of the rings, with gaps, divisions, and structures that scientists had never expected. Voyager 1 revealed Saturn's rings in their true form, a beautiful, intricate web of ice and dust, a cosmic masterpiece floating in space. But Saturn's rings were not the only remarkable feature that Voyager 1 uncovered. The spacecraft also observed the planet's atmosphere, revealing details about its cloud structure and winds. The planet's atmosphere was a swirling mass of gases, with winds reaching speeds of up to 1,100 miles per hour. Voyager 1 data showed that Saturn's atmosphere was not just a calm, steady mass, but a dynamic, ever-changing system. Perhaps most fascinating of all were the moons of Saturn. There were over 60 known moons orbiting Saturn, and as Voyager 1 passed by, it captured the first close-up images of some of these moons. Among the most intriguing was Titan, Saturn's largest moon, with a thick atmosphere of nitrogen and methane. Titan had long been a subject of scientific interest, and Voyager 1 flyby offered the first glimpse of this enigmatic moon. Although the thick atmosphere prevented scientists from seeing Titan's surface in detail, they could detect its hazy, orange glow. This discovery sparked further missions to Titan, including the Cassini-Huygens mission, which eventually landed on the moon's surface in 2005. Voyager 1 discoveries didn't just extend to the planets and moons of the outer solar system. The spacecraft also made important contributions to our understanding of the solar wind, cosmic rays, and the interstellar medium. The solar wind, a stream of charged particles emitted by the sun, interacted with the planets in ways scientists had not fully understood. Voyager 1 data helped to map out how the solar wind interacted with the magnetic fields of Jupiter and Saturn, providing insights into how the sun's energy influenced the far reaches of the solar system. But the most significant discovery was the one that no one expected. Voyager 1 had uncovered new, hidden realms of space. As the spacecraft ventured beyond the orbit of Saturn, it began to send back data that suggested something beyond the familiar planetary boundaries. As it passed through the edges of the solar system, it started to encounter a strange, quiet space, a space where the solar wind's influence began to fade away. It was the beginning of an incredible journey, one that would eventually take Voyager 1 into the uncharted reaches of interstellar space. This first glimpse of the gas giants was just the beginning of the Voyager missions. What they had already revealed about Jupiter and Saturn was astonishing, but the true significance of these discoveries was still unfolding. The images and data sent back by Voyager 1 and 2 would serve as a foundation for generations of space exploration. They had uncovered the unexpected, the unknown, and the mysterious, and they had shown humanity that the universe was much stranger and more beautiful than anyone could have imagined. And so, as Voyager 1 and 2 continued their journey deeper into the unknown, the discoveries would keep coming, each more incredible than the last. These two spacecraft, designed to explore the farthest reaches of the solar system, had already made their mark on the history of space exploration. But the real journey was just beginning. This second part continues the fascinating journey of the Voyager missions, focusing on the discoveries of Jupiter and Saturn, their moons, and the unprecedented data returned by the spacecraft. The cinematic style aims to keep the audience captivated with suspense, mystery, and the awe-inspiring nature of space exploration. As Voyager 1 and 2 journeyed deeper into the solar system, they were about to face their most breathtaking challenge yet. Saturn, the jewel of the outer solar system. A planet that had been the subject of fascination for astronomers for centuries, Saturn was known for its stunning, iconic rings, but no one could have predicted just how astonishing those rings would appear up close. For decades, scientists had speculated about the composition of Saturn's rings, but nothing could prepare them for the breathtaking images that would come from Voyager 1's close encounter. By November 1980, Voyager 1 had finally arrived at Saturn, ready to unlock the mysteries of this gas giant and its surrounding rings. The excitement at NASA was electric. This was a once-in-a-lifetime event. There would be no going back, no second chances to capture the planet's most intimate details. The spacecraft was prepared, its cameras aimed at the rings that had captured humanity's imagination. But no one was fully prepared for the stunning revelations that were about to unfold. The first images transmitted back to Earth revealed the breathtaking complexity of Saturn's rings. The image showed Saturn's rings stretched out like a vast, intricate mosaic, a swirling dance of icy particles, ranging in size from tiny dust grains to enormous chunks of ice and rock. The beauty was mesmerizing, an exquisite celestial arrangement that seemed almost impossible to comprehend. The sheer scale of the rings, with their delicate multi-layered structure, was something that could not have been fully understood from Earth-bound telescopes. Voyager 1 images were the first to reveal just how vast and detailed Saturn's ring system truly was. One of the most surprising discoveries was that Saturn's rings weren't a uniform structure, as previously thought. Instead, they were composed of thousands of smaller individual rings separated by gaps, some of them almost empty of particles, while others were densely packed with ice and rock. This structure, which came to be known as the ring gap, indicated that Saturn's rings were not merely static features, but dynamic, changing systems. The size of the particles varied greatly, from the finest dust to chunks that were as large as mountains. Some of the larger particles cast long shadows against the bright backdrop of Saturn, giving the rings a dramatic, almost otherworldly appearance. Voyager 1 also made an incredible discovery. The rings were not solid. They were made up of billions of tiny particles, each orbiting Saturn in an elaborate, almost choreographed manner. The spacecraft showed how these particles interacted, their movements influenced by the gravitational forces of Saturn's moons. These moons, which were scattered throughout Saturn's rings, created disturbances in the ring structure. Some moons, called shepherd moons, kept the rings in place, ensuring that the particles didn't drift away. Others were the source of gaps in the rings, which were created by gravitational forces that cleared the space between the particles. As Voyager 1 continued its flyby, it passed closer and closer to the rings, capturing images that would forever change humanity's understanding of Saturn and its surrounding system. The spacecraft passed through the ring plane, the flat, thin disk of Saturn's rings, gathering data on their composition and structure. The spacecraft sent back detailed images of the ring's surface, revealing that they were made mostly of ice and dust particles. These particles were constantly colliding and breaking apart, creating a dynamic environment that was far more active than anyone had realized. The data from Voyager 1 also revealed something even more unexpected: the existence of small moonlets within Saturn's rings. These tiny moonlets were not much larger than a few kilometers across, but they were causing the rings to behave in fascinating ways. Voyager 1 detected the gravitational influence of these tiny objects, which helped scientists understand how the rings were not a single, unchanging structure, but rather a dynamic and evolving system. The discovery of these moonlets raised even more questions. How had these small moons formed? Were they remnants of a larger moon that had been torn apart by Saturn's gravity? The information Voyager 1 provided about Saturn's rings also helped scientists learn about the planet's history. It was clear that the rings were not permanent. They were constantly changing, reshaping themselves over time. Some of the particles in the rings were believed to have been part of a moon that was destroyed by Saturn's gravity long ago, while others had likely come from comets or asteroids that had ventured too close to the planet and were torn apart by its powerful forces. In essence, Saturn's rings were an ongoing story of destruction and creation, a reminder of the planet's immense gravitational pull and its ability to reshape the cosmos. However, while Voyager 1 encounter with Saturn's rings was awe-inspiring, the spacecraft wasn't just capturing beautiful images. It was collecting valuable scientific data that would deepen humanity's understanding of the planet's atmosphere, magnetic field, and moons. Voyager 1 analyzed the composition of Saturn's atmosphere, which was made up primarily of hydrogen and helium, just like Jupiter's. However, Saturn's atmosphere was much colder, with temperatures dropping to a bone-chilling -290 degrees Fahrenheit, -179 degrees Celsius. The spacecraft also took measurements of Saturn's magnetosphere, revealing how the planet's magnetic field interacted with the solar wind, a stream of charged particles emitted by the sun. The most significant moment of Voyager 1 flyby of Saturn, however, came when the spacecraft passed through a region of space known as the Cassini division. This dark gap in the rings, named after the astronomer Giovanni Domenico Cassini, was a region where the rings appeared to be empty. But as Voyager 1 passed through, it found that this gap was not completely void. It was filled with very small particles that were too tiny to be detected by earlier telescopes. These findings provided key insights into the formation of Saturn's rings, revealing that even the darkest gaps were not truly empty. At this point, Voyager 1 was at the edge of its journey through Saturn's system. The spacecraft's flyby of Saturn was brief, lasting only a few months, but the discoveries were groundbreaking. The spacecraft had not only captured detailed images of Saturn's rings and moons, but it had also provided essential data that would guide future missions to the gas giant. The data from Voyager 1 was the first to suggest that Saturn's rings were far more complex than anyone had realized, and that the gas giant was more than just a pretty face in the sky. The mission had also set the stage for future spacecraft to explore Saturn in even greater detail. Voyager 1 brief encounter had unlocked an entire world of mysteries, many of which would be revisited and expanded upon by future missions, including NASA Cassini spacecraft in 2004. But even as Voyager 1 left Saturn behind, the mission was far from over. The spacecraft's journey was far from finished. The mysteries of Saturn were only a glimpse of the deeper unknown that lay ahead. As Voyager 1 continued its journey into the outer solar system, the discoveries kept coming, each more amazing than the last. Its next destination was beyond the familiar borders of the solar system, into a region that no spacecraft had ever ventured before: interstellar space. While Voyager 1 was making its final pass through Saturn's system, its twin, Voyager 2, was preparing to follow a similar path, but with a unique twist. Voyager 2 was set to become the only spacecraft to visit all four of the gas giants: Jupiter, Saturn, Uranus, and Neptune. The journey of both Voyagers was a race into the unknown, and with each passing year, the spacecraft sent back valuable information that would forever shape the future of space exploration. The passage through Saturn's rings was a moment in history, a moment when the universe opened its secrets to humanity. But as Voyager 1 continued on its way, the story of these two spacecraft was far from finished. Their journey into the depths of space was only beginning. What other wonders lay beyond Saturn? What mysteries would they uncover next? The answers were waiting out there in the great unknown, just beyond the reach of our imagination. This third part of the documentary highlights Voyager 1 historic flyby of Saturn and its spectacular rings. It builds on the suspense and curiosity of the previous sections, adding layers of mystery and wonder that keep the audience engaged and eager for what comes next. The cinematic style continues to paint vivid pictures of the spacecraft's discoveries, while laying the groundwork for the next phase of the journey as the twin Voyager spacecraft continued their journey through the outer solar system. A new extraordinary phase awaited them. After completing their groundbreaking encounters with Jupiter and Saturn, they now faced the distant, ice-cold giants that had never been visited by any spacecraft before, Uranus and Neptune. These two mysterious planets were among the least understood, hidden in the outermost reaches of our solar system, far beyond the realms of the gas giants. They were often referred to as the ice giants, and their secrets were waiting to be unlocked. But these planets posed an entirely new set of challenges. Unlike Jupiter and Saturn, which had been relatively straightforward in their exploration, Uranus and Neptune were much farther away, making any attempt to explore them seem like an impossible task. No spacecraft had ever ventured so far into the deep solar system, and no one knew exactly what to expect when Voyager 2, chosen for this monumental task, finally arrived at these distant worlds. Would they find only cold, barren ice worlds, or would they uncover something more extraordinary? Voyager 2 journeyed to Uranus. The first encounter in 1986, Voyager 2 reached its first destination, Uranus. This was a remarkable achievement. Uranus, discovered in 1781 by William Herschel, had been a subject of fascination for astronomers for centuries, yet it remained largely unexplored. With its faint rings and tilted axis, it was a planet unlike any other in the solar system. Its atmosphere, composed mainly of hydrogen, helium, and methane, gave it a distinct blue-green color. But little was known about its composition, magnetic field, or even its moons. Voyager 2 approach to Uranus was the first time humans had the opportunity to study this ice giant up close. The spacecraft passed just 81,500 miles, 131,000 kilometers from the planet, capturing crucial data about its atmosphere, magnetic field, and moons. As Voyager 2 made its flyby, it was clear that Uranus was not the cold, lifeless world that many had assumed. It was dynamic, fascinating, and full of surprises. One of the most startling discoveries was the planet's tilted axis. Uranus is unique among the planets in the solar system because its axis of rotation is tilted by a staggering 98 degrees. This means that the planet essentially rotates on its side, unlike any other planet, making its seasons and weather patterns completely different from those of Earth or any of the other gas giants. Voyager 2 revealed that Uranus's extreme tilt likely resulted from a massive collision with another object early in its history, which knocked the planet onto its side. This tilted axis explained the bizarre weather patterns observed on the planet. Scientists now understood that Uranus experiences extreme seasons, with each pole facing the sun for about 42 years at a time, before shifting to the opposite pole. Voyager 2 also revealed that Uranus has a faint ring system, 5 rings to be exact, made up of dark, icy particles. These rings, unlike Saturn's elaborate shining rings, were much smaller and fainter. But their discovery was groundbreaking because they showed that even far-flung, icy worlds like Uranus could have complex ring systems. Some of the rings appeared to have strange, uneven structures, indicating that they were influenced by small moons orbiting the planet. Perhaps the most exciting discoveries, however, came from the spacecraft's observations of Uranus's moons. Voyager 2 revealed that Uranus had at least 27 known moons, many of them strange and unique in their own right. The largest moon, Titania, was observed to have large canyons, craters, and evidence of ancient geological activity. Another moon, Oberon, appeared to have a heavily cratered surface, suggesting that it had been subject to intense bombardment over billions of years. Voyager 2 also found signs of frozen water beneath the surface of some of these moons, a discovery that hinted at the possibility of subsurface oceans, a feature that would later be confirmed on other icy moons in the outer solar system, like Europa. As Voyager 2 continued to gather data on Uranus, it became clear that this icy giant was not the cold, inert planet many had thought. It was a dynamic, active world, with a complex history and intriguing potential for future exploration. The spacecraft's flyby of Uranus marked a major milestone in space exploration, and the data it returned would set the stage for future missions to explore these distant, frozen worlds. Voyager 2 Journey to Neptune. A final frontier after its successful flyby of Uranus, Voyager 2 was not done. It had one more ice giant to visit, Neptune, the most distant planet in the solar system at the time. Reaching Neptune would take the spacecraft to the very edge of the solar system, to a place where no human-made object had ever gone before. And it was here, in the cold, dark reaches of the solar system, that Voyager 2 would make its most astonishing discoveries yet. In 1989, Voyager 2 passed just 3,000 miles, 4,800 kilometers from Neptune, making its closest approach to any of the outer planets. The data sent back from the spacecraft revealed an utterly unexpected world. Neptune, unlike its icy sibling Uranus, was a vibrant, dynamic planet. Its deep blue color, a result of the methane in its atmosphere, was stunning to see in the images sent back by Voyager 2. But it wasn't just the color that stood out, it was Neptune's weather system. Neptune's atmosphere was full of incredible features, including violent storms that seemed to rage across the planet. The most famous of these storms was the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. The Voyager spacecraft revealed that this storm was dynamic, changing in size and shape over time. The storm had an interesting twist. It appeared to disappear entirely just a few years after Voyager 2 flyby, indicating that Neptune's weather systems were not only active but also highly changeable. The spacecraft also found evidence of fast winds, some reaching speeds of up to 1,200 miles per hour, 2,000 kilometers per hour. These winds were among the fastest ever recorded in the solar system, a phenomenon that puzzled scientists for years. But the discoveries didn't stop there. Voyager 2 also discovered Neptune's rings, which were faint and difficult to observe from Earth. Unlike Saturn's brilliant rings, Neptune's rings were dark, made up of ice and dust particles. The spacecraft observed that these rings were not uniform but contained gaps and clumps of material, a feature that scientists found intriguing. The data sent back by Voyager 2 also suggested that Neptune's rings were much younger than Saturn's and might even be the result of a collision with a small moon or comet. The most stunning discovery, however, came from Neptune's largest moon, Triton. Voyager 2 revealed that Triton was a world unlike any other moon in the solar system. It had a retrograde orbit, meaning it orbited Neptune in the opposite direction of the planet's rotation, an unusual feature that suggested Triton might have been captured by Neptune's gravity rather than forming alongside the planet. What was even more remarkable was the presence of geysers, plumes of nitrogen gas and ice erupting from the moon's surface. These geysers were active and seemed to be driven by internal heat, which was surprising given Triton's frigid surface temperature of around -390 degrees F, -235 degrees C. This discovery opened up the possibility that Triton had a subsurface ocean, similar to Europa and Enceladus. As Voyager 2 continued to gather data, it became clear that Neptune, like Uranus, was a complex and dynamic world. Its storms, winds, rings, and moons made it a treasure trove of scientific discovery. The data sent back from Voyager 2 would form the basis for future studies of the ice giants and help guide the exploration of other distant, icy moons and planets. The significance of the Voyager missions. A journey to the outer limits, the Voyager missions were nothing short of extraordinary. They had taken humanity to the outermost edges of the solar system, to the icy worlds of Uranus and Neptune, and had unveiled their secrets in ways no one had imagined possible. Voyager 1 and 2 had shown us the complexity and beauty of our solar system's distant planets, providing data that would fuel scientific inquiry for decades to come. But perhaps the most remarkable part of the Voyager missions was not the planets they explored, but the journey itself. Voyager 2, in particular, had traveled farther than any spacecraft before it, sending back invaluable information from the far reaches of the solar system. With each passing year, the spacecraft ventured farther from Earth, continuing to send back data about the interstellar medium, the region of space beyond the solar system's influence. The twin Voyagers had done what no one thought possible. They had become humanity's most ambitious explorers, venturing into the unknown and returning with revelations that expanded our understanding of the cosmos. Their discoveries about Uranus, Neptune, their moons, and the very nature of the outer solar system would forever change our understanding of the universe. As the spacecraft journeyed farther into space, there was a sense of awe and anticipation. What else could the Voyagers discover as they ventured into interstellar space? The story of Voyager 1 and 2 was not just the story of space exploration. It was the story of humanity's curiosity, our desire to push the boundaries of knowledge, and our quest to understand the mysteries of the cosmos. This fourth part of the documentary highlights Voyager 2 historic flybys of Uranus and Neptune. The narrative is rich in scientific discoveries, maintaining the sense of awe and mystery that has captivated audiences throughout the journey. The cinematic style builds suspense and excitement, keeping the viewer engaged as the spacecraft unveil the hidden secrets of the outer solar system as Voyager 1 and 2 journeyed farther into the deep, cold reaches of space. They were not only embarking on an incredible scientific mission, but they were also carrying a profound message. A message that spoke not only of our curiosity and intelligence, but of our humanity. It was a message that transcended time and space, a message for any extraterrestrial civilizations that might one day find these spacecraft, drifting silently among the stars. This was the Golden Record, a remarkable artifact created by NASA to represent life on Earth, and perhaps humanity's first attempt to communicate with the universe. It is easy to think of space exploration as a purely scientific endeavor, a search for knowledge about the universe. But the Golden Record was different. It wasn't just about gathering data or mapping out the stars. It was about sending a piece of humanity into the vast unknown, a message that said, "We were here." The Golden Record was designed to be a time capsule, one that would carry the essence of Earth, its people, its cultures, its sounds, and its music into the farthest reaches of space. It was a symbolic gesture, one that reflected both our desire to connect with the cosmos and our deep-seated hope that we are not alone. The creation of the Golden Record was spearheaded by Carl Sagan, one of the most renowned astronomers of the 20th century, and a team of scientists, artists, and musicians. The idea behind the record was simple. If an intelligent civilization somewhere out there in the universe were to find it, they would be able to learn something about Earth and its inhabitants. The record would serve as a kind of greeting, a universal message from humanity to the stars. But creating such a message was far from simple. How could you possibly communicate with an alien civilization that might not even have the same concept of sound, language, or technology? The first challenge was determining what information to include. The Golden Record would have to be a snapshot of Earth, a brief but representative collection of sounds and images that could speak to an alien intelligence. So, the team selected a wide variety of content that spanned humanity's diversity. For example, they chose 55 different languages for greetings, including ancient and modern languages, from Sumerian to Chinese to English. The hope was that no matter where or how the message was found, it would be clear that it was meant to communicate across the stars. But the Golden Record wasn't just about words. It was also about the sounds of life on Earth. The team carefully selected sounds that represented the diversity of human experience. Laughter, the sound of a kiss, the sound of a heartbeat, the roar of a lion, the crashing of ocean waves. They even included a recording of a whale song, a hauntingly beautiful sound that represented the Earth's oceans, and by extension, the planet's interconnected life. These sounds were chosen because they conveyed the rhythms of life itself, in all its beauty, complexity, and mystery. The music on the Golden Record was just as carefully curated. The team included a selection of musical works that spanned cultures and time periods, from the traditional music of various indigenous cultures to the works of composers like Bach, Beethoven, and Stravinsky. They even included a piece of traditional West African drumming and a piece of Indian classical music, hoping to give a sense of the diversity of human creativity. The idea was that music might be a universal language, one that could transcend the barriers of culture and communication. The physical format of the Golden Record was as important as its content. The record itself was a 12-inch gold-plated copper disc, chosen because of its durability. The disc was inscribed with a pictorial cover that included diagrams showing how to play the record, along with instructions in symbolic form to help any future extraterrestrial finders understand how to use it. The cover also depicted a map of Earth's location in the galaxy, using pulsar timing as a reference point, in case the finders needed to know where the message came from. Along with the Golden Record, there was a stylus included, basically a needle so that the recipient could play the record and understand its contents. When the two Voyager spacecraft were launched in 1977, the Golden Record was attached to each spacecraft, nestled securely in a compartment designed to protect it from the harsh environment of space. The records were not meant to be just a scientific tool. They were meant to be an eternal message to the universe, one that would outlast the spacecraft themselves. As Voyager 1 and 2 sped further from Earth, the Golden Records traveled along with them, carrying humanity's first attempt to communicate beyond our solar system. The symbolism of the Golden Record, the very existence of the Golden Record, is a testament to humanity's deep desire to reach out and make contact with something greater than ourselves. The idea of sending a message to the stars speaks to our fundamental curiosity and our desire to connect. The Golden Record was a bold statement that humanity, in its time of uncertainty and division, was united by a shared sense of wonder about the universe and our place in it. In many ways, the Golden Record reflects the very spirit of the Voyager missions. Both were designed to push the boundaries of human knowledge and to reach beyond the limits of our understanding. The spacecraft, in their silent journey through space, would carry this message of hope and discovery, broadcasting our existence to the cosmos. Whether or not the Golden Record would ever be found by intelligent life was uncertain. After all, the record was designed to last for billions of years, and the likelihood of it being discovered was incredibly small. But the act of sending it was profound, an act of faith in the vastness of the universe and our ability to connect with it. This symbolic gesture also had a practical aspect. As Voyager 1 and 2 left the solar system behind, they became humanity's ambassadors to the stars. The Golden Record, in a very real sense, carried with it the legacy of our species. It was an invitation to anyone or anything out there to understand who we were, what we had achieved, and what we had hoped for in the future. The message was as much about humanity's diversity, creativity, and intelligence as it was about our vulnerabilities and our place in the vast cosmic web. The legacy of the Golden Record, what if it is found? Even though the likelihood of an alien civilization encountering the Golden Record is infinitesimally small, the very thought of it is captivating. Imagine for a moment an intelligent species from another star system discovering one of the Voyager spacecraft, its message preserved on the Golden Record, waiting to be unlocked. What would they make of us? How would they interpret the music, the sounds, the greetings, the images? Would they find our attempt to communicate as a form of universal kinship, or would they be puzzled by our efforts? Over the years, the Golden Record has inspired both hope and reflection. It reminds us of the vastness of space and the fleeting nature of our existence. The golden disk, drifting silently through interstellar space, is a symbol of both our yearning to understand the universe and our fragile temporary place within it. And perhaps most importantly, the Golden Record is a reminder that, despite our differences, we share something fundamental with every other life form in the universe: a desire to communicate, to understand, and to be heard. In the decades since the Voyager missions launched, scientists, artists, and thinkers have continued to reflect on the significance of the Golden Record. It has become an iconic symbol of human exploration, not just of the physical universe, but of our own collective identity. It speaks to our eternal quest for connection, for understanding, and for discovery, no matter how far or how long that journey might take. The Golden Record and the future of space exploration as Voyager 1 and 2 continue their journey through the cosmos, leaving the solar system behind. The Golden Record remains their most lasting legacy. The spacecraft, now in interstellar space, are still transmitting data, slowly fading as their power wanes, but their message, carried by the Golden Record, remains. Whether or not the Golden Record will ever be found is uncertain, but its message will endure. It is a message that says, we were here. It is a testament to the curiosity, creativity, and hope of humanity, carried into the farthest reaches of space. Voyager missions and the Golden Record represent more than just a technological achievement. They represent the very essence of human nature, the desire to explore, to understand, and to communicate. Whether or not the message ever reaches another civilization, the act of sending it is an expression of humanity's deepest aspirations. It is a gift to the stars, a message of peace, curiosity, and hope for the future. As we look to the future of space exploration, the legacy of the Golden Record serves as a reminder of what we have already accomplished and the limitless possibilities that lie ahead. The Golden Record is more than just a time capsule. It is a symbol of humanity's place in the universe, a place where we are not only observers of the cosmos but active participants in the grand journey of exploration. And as we continue to push the boundaries of our knowledge, the Golden Record will remain a silent witness to our enduring curiosity, carried into the stars forever. This fifth part of the documentary focuses on the Golden Record and its significance within the Voyager missions. It emphasizes the symbolic nature of the Golden Record, reflecting humanity's desire to communicate with the universe. The cinematic storytelling style continues to capture the wonder and mystery of space exploration, blending both scientific achievement and the deep philosophical questions that arise from our exploration of the cosmos. The Voyager spacecraft had been on an extraordinary journey, a mission that took them farther than any human-made object had ever ventured before. The discoveries they made about the gas giants, the icy moons, and the distant realms of our solar system were groundbreaking. Yet, as they left the known planets behind, a new chapter was about to begin. Voyager 1 and 2 were about to cross a boundary that no spacecraft had ever crossed before, the boundary between the solar system and the mysterious expanse of interstellar space. Interstellar space is the region between the stars, the vast emptiness that lies beyond the influence of the sun and the solar wind. It is a place where the familiar forces of the solar system, the sun's gravitational pull, its radiation, and its solar wind no longer dominate. Beyond this boundary, the vastness of the galaxy stretches out, a realm of cosmic radiation, dark matter, and unknown possibilities. The first time humanity was sending something into this uncharted territory, and the Voyager spacecraft were the pioneers, leaving the safety of the solar system and entering the great unknown. But this wasn't just a journey into space, it was a journey into time. The spacecraft had traveled across vast distances through the asteroid belt, past Jupiter and Saturn, beyond Uranus and Neptune, to a place where the cosmic environment began to change. The space